Hello, welcome back to Mr. Powers Teaches Algebra. We are algebraing it up. Uh-oh. Hold on one second. All right, we're back. Here we go. So we're talking about function composition today. You'll love to see it. It's amazing. Here it is. The composition of f of x and g of x, note the order here, is f of g of x. That's how we say it. Both of these, we say, f of g of x. That is how we say both of these, and this is our two different notations. One, again, is good for technology. That is this one here is the one we'll prefer to use when we're entering something into a calculator. But when we're writing or reading in a book, we may see this other one right here. They mean the same thing, just different ways to write the same thing. And likewise, we have g of f of x right here, which is a little bit superfluous, unnecessary. Now, the thing is, though, we're writing both. G of f of x is not going to give you the same result as f of g of x. They will result in different outcomes, okay? So I encourage you, when we do an example or when you see an f of x, g of x, play around with it. Do both. And I may do one right now where we do f of x and g of x. And something also to note, as you might notice from this example I just popped up on the screen, is that f times g of x is certainly not the same as f of g of x. All these are different, okay? So let's do all of these right now. I will start off with f of g of x first, just in case you're convinced and you understand everything I've said before. We'll only go over f of g of x first, so you can quit this video as soon as you know what you're doing, okay? So f of g of x, that means f of g of x. This is the way I like to write it. We could use brackets right here instead if you really want to, right there. That is perfectly fine too. It may be even easier to read, but I'm stuck in my ways and I'm just going to leave it like that. So what does that mean? Well, f of x, right? F of x, if I wrote f of x, what is it? That's 2, because f is outside. F is my function outside. So I really have f of g of x instead of f of x, right? F of x, let's write that above it, is 2 plus 3x minus x squared, okay? But what I'm going to do is instead of x, I have g of x. So it is the same exact philosophy, the same exact thinking as before, okay? So here's x, here's x. Okay. And that is whatever's in place of x is what we're going to put in there. So a couple ways I could do it. I mean, if I want to take it really slow, I could say 2 plus, I'm using blue here. I can say 2 plus 3 times g of x minus g of x squared. I could do that if I want. That is literally what it means, okay? Just like it always has meant. If you are comfortable with function notation, you already know this. Without being told, you should know, hey, just, plug it in. But we also have an expression. We know what g of x is. It's 2x minus 1. So that means I can go further, and I can replace that g of x with 2x minus 1. So that's what I'll do. 2x minus 1. So now it's 2 plus 3 times 2x minus 1 minus 2x minus 1 squared. And that's it. That's all there is to it. Very, very simple. So now we just simplify. Hard part is done. Now the easy part. So 3 times 2x minus 1, that's 6x minus 3. And then we have negative 2x minus 1 squared. So let's say minus, let's be really careful here. 2x minus 1 squared, what is that? It's going to be 4x squared minus 4x plus 1. Pretty sure. And then distribute the negative. So 2 plus 6x minus 3 minus 4x squared plus 4x and minus 1. And now we can combine like terms and finally get to our answer. 2 plus, so combine like terms. What am I doing here? What am I doing? X squareds. Okay, we got a negative 4x squared. Let's see here. Our x's, we got a 6x, we got a 4x. Okay, so that's plus 10x. And then we have our numbers. There's a 2 plus negative 3 is negative 1 plus negative 1 is negative 2. There it is. Woo! So this is what we get for f of g of x. F of g of x. All right, neat. All right, that's it. That's how we do it. Now, f times g of x, I'm not going to bore you here, but I'll get it started, for instance, and I'll let you finish this, and you'll be able to see very easily, okay, that these answers are different. And if you want to see them worked out step by step, they're in our notes. So f times g of x, that means f of x times g of x. And I think through a quick inspection, we can see obviously this will not be the same thing, because f of x is 2 plus 3x minus x squared times g of x, which is 2x minus 1. And I don't know about you, but I can see here that I'm going to have a negative x squared times a 2x. That's going to give me a negative 2x cubed. There is no x cubed in here. These will be different. It is obvious already. Those are not going to be the same. So right there, we already know. Definitely don't confuse multiplying with function composition. And then g of f of x, I'll get that one started for you as well. And I encourage you to do that on your own. And I'll even tell you what the answer is. But I won't bore you with the details here in our video. And let's see here. So g of f of x is going to be g of f of x, like this. So that means I'm plugging f of x in for g. So what is g? G is 2x minus 1. So instead of 2 times x minus 1, oops. Instead of 2 times x minus 1, I'm not going to have an x. It's going to be f of x. So f of x, where are you? Where is f of x? F of x is 2 plus 3x minus x squared. There. So if you work all that out, what should you get at the end? We work all that out. G of f of x should be negative 2x squared, negative 2x squared plus 6x plus 3. That's what you should get. So I encourage you, work that out. See if it works out the way it's supposed to, and we'll be in good shape. So that's it for this video on function composition. Hope you enjoyed it. Got questions, let me know. Until next time, enjoy doing math.